My hands are often busy, but I want to access the functions on my smartphone, even though my hands are in use. So, I mounted my phone right here, and via this mirror right here, it's always visible in the periphery of my vision. To control it, I simply give my head a pop, and it turns on a mouse. Now, by tilting my head up and down, I can control where the mouse goes. A simple tap of my foot clicks the mouse. That gives the accelerometer in here just enough of a jolt that it registers as a tap, and then we can translate that into a click of the mouse. Now, using voice to text, I can access the keyboard function. In the next revision of this thing, figure out how to support gestures. And what you just saw there was me recording a brainstorm. Now, of course, I can also head over and respond to texts as they come in. I can also, of course, head up here and check the weather. This has gradiated control, so the further I tilt my head up, the faster the mouse moves. The further I tilt to the right, the faster it moves in that direction. I can also listen to audiobooks, music, or podcasts because I have Bluetooth in here, inside these headphones. Or when we want to access the pinout of our Raspberry Pi Pico. Now when I want to turn it off, all I have to do is shake my head one more time. The accelerometer registers that as a shake, and now when I tilt my head, the mouse no longer moves, and it will eventually disappear. Inside of this we have a Raspberry Pi Pico and an accelerometer. The accelerometer registers the position of my head and then feeds that information to the Raspberry Pi Pico, which translates it into movements of the mouse. That Raspberry Pi Pico acts like a USB mouse, which is then plugged into our cell phone, and using all of that we can control the cursor on our mouse. This is a really simple build. The whole thing only costs about $15, and you get a phone that's always visible in the periphery of your vision and control of it via a mouse for about $15. Pretty good deal. Now, I use this when my hands are busy, but perhaps you're somebody who can't use your hands to control a smartphone, but you can move your head, in which case this may be for you. There's probably an accessibility use case here. It is all open source. Go ahead, give it a shot, develop it, and if you have ideas for what you'd like to see, let me know and I'll give it a shot. In this video, I'm going to explain how this thing works and then how it's built. It's all very simple, and I think it's got a lot of room for expansion in future revisions. So how does this work? Well, you drop your phone into this case right here, and you have two mirrors. This one is at a 45-degree angle, which sends the image right out this way, and this one's at about a 15-degree angle, which directs it back towards your eyes, sitting right here. Now, the distances involved are about 12 inches total on average between those two mirrors, and about 6-7 inches between your eyes and this mirror right here. The total result is like holding your phone 20-something inches, 20-21 inches from your face, which is like 2/3 of an arm length. It's a reasonable place to hold your phone. Everything looks just like it would be if you were holding this thing up in front of your face. But of course, it's mounted over here, and so the headset is able to support it. Now, we do have to turn the phone brightness up, because if we don't, these mirrors are not great mirrors. They will lose brightness on the way to your face. In the future, I'd like to make these real glass mirrors, and then we don't have to adjust the brightness of the phone. So that's how you get an image to your face. Once you have that, then you're going to rely on the Pi Pico plus the accelerometer stuffed in there and then connected via USB into your phone so that you have a mouse control. And this is true of all, both iPhone and Androids. If you plug a USB mouse into the bottom there, it will give you a cursor and you can move around and click things just like, it's a computer. The accelerometer inside of here is what actually controls the function of the mouse. You can see that it's set at an angle. So forward on the accelerometer is the same direction that your face is facing when you're wearing this headset.
That means that you have one axis of the accelerometer pointing the same direction as your eyes. A second one is perpendicular to your eyes. You can think, the direction of your ears. And then one is straight up and down. This is a 3-axis accelerometer like you'd find in your cell phone. Now, it has a special function, which is it detects shakes. Now, a shake is just essentially a lot of acceleration over a very short period of time. So when we do this with our head, the accelerometer actually detects that as something special, and it sends a signal that says that was a shake. Now, that's a unique movement. That sort of high acceleration in a very short period of time isn't something that you're going to do unintentionally. So in the Raspberry Pi Pico, we can use that to say, we just turned on or off the mouse function. This accelerometer is constantly spewing out the acceleration values in the X, Y, and Z axes, but most of the time the Raspberry Pi ignores them. Only when it sees one of those shake events does it start paying attention to the values and then calculating how it should move the mouse. That's how we can keep the mouse unused most of the time until we detect one of those head shakes and then start moving the mouse in whatever direction the orientation of your head is. The same thing goes for turning off the mouse so that now you won't accidentally be moving the mouse and clicking things while you're out working. So if you picture the X, Y, and Z axis, you've got, they're approximately like this. Gravity is always pulling them down. So the Z-axis is feeling the full force of gravity in a approximately neutral head position. The axis that goes through your ears and the one that goes through your eyes is essentially not exposed to gravity. They're being pulled down, but they are orthogonal to gravity when they're in a neutral position or somewhere near zero. So the values that come out of the X and Y axes are usually close to zero. It's not until you deflect your head down that now this axis is being pulled somewhat by gravity. If you deflect your head further down, it's now being pulled more strongly by gravity. So the values of the accelerometer on that axis go from 0.1 to 0.2 to 0.3. The same thing goes for through your ears. Now if you look to the left and right like this, that axis is still orthogonal to gravity. It's only when you twist your head like this that you've now started to expose that axis to gravity, and the values will go from 0 to 0.1 to 0.2. Now what you do with those values is your choice. I chose to make small deflections like this, only move the mouse a tiny bit, say 2 pixels. And as you increase the amount of deflection that your head is producing, it goes from say 2 pixels to 10 pixels to 30 pixels to 80 pixels. And what that does is it accelerates mouse movements. If you only deflect a little bit, you'll get very fine-grained movements. If you deflect a lot, the mouse will really jump down the screen quickly. That allows you to navigate the screen really quickly if you choose, but then have precise control when you need it so that you can zero in on a particular thing. Last, we have not used the Z-axis readings at all. We actually only pay attention to X and Y readings when we want to move the mouse around. The Z-axis is left free to detect taps. That's another special function of this accelerometer. Your cell phone probably has the same thing. But when there's a small movement over a very short period of time in the Z-axis, we can interpret that as a tap. So it could be a head bob or a stomp of the foot, and that's enough to register as a tap, which is again sent as a special signal to our Raspberry Pi, and then the Raspberry Pi takes that and turns it into a mouse click.
Now it's time to have a look at the code that actually makes this go. There's not a whole lot out here in the HeadTurner repository of Nathan Builds DIY, but we're going to look at two things. First is this lib directory. These are libraries taken from Adafruit. They do two functions. One is make this Raspberry Pi Pico look like a USB mouse. That's the Adafruit HID directory here. And then we've got a couple files that interface with our accelerometer and get the, they're able to read things from the accelerometer. And the only other file that does something useful out here is this code.py. And there isn't a whole lot going on in here. It's like 100 lines, maybe just a little bit more. And we're going to jump all the way down here to this while loop to see how it actually runs. So this is just an infinite loop that reads the values of the accelerometer and then translates it into mouse movements. And I mentioned that we're using this LAS3DH accelerometer, and it has a special shake function. So in this loop, what we do first off is check to see if we've had a head shake. That's how we turn on and off the mouse function. So we're only going to actually take readings from it if we detect a shake. Now you see just above this here, it also looks at a button. I initially thought I was going to use a button to turn on and off the mouse function. And the code still exists. There's even a hole in the 3D printed file where you could put a limit switch. If you would like to use a button to turn this on and off, you just hook it up between GPIO 16 and ground, and this code will kick in. The difference between these two is just below here. When we detect that there is a head shake, we drop into, or a button press, we drop into this block of code right here. And if there's a head shake, we violently change the accelerometer values when we shake our head. That's what is a shake. It's a pretty strong movement of the accelerometer. So then we wait a half a second so that our head can get back to a neutral position and the accelerometers can neutralize before we read those values and use them as our reference. This is the position of a neutral head. If we've clicked the button, we don't wait that long. We just go ahead and read it right away. So this is sort of the important bit. Well, there's two important bits here. This one where we read the neutral values of our accelerometer. So, what is our neutral head position so that we can calculate mouse movements off of that. And then we also toggle this mouse move flag right here. So this is how we turn on and off the mouse function. When we detect a shake or a button press, we just change it from on to off or off to on. So now that we're armed with those two things, assuming we've turned our mouse move flag to true, we can drop into this bit of code down here, still in that same while loop. So we're just iterating over this. We do two things once we have the mouse turned on. The first is we look for a tap. Now this is another function that this accelerometer provides through that same INT pin that the shake command comes through. It's a tap. And you can think of this as a very mild shake. Or more precisely, it's like if you tapped your finger on your phone, it actually registers, it seems, as a Z-axis change. So you can bop your head up and down, or I like to stamp my foot because that's a pretty reliable little just jostle in the Z-axis. Doesn't take a whole lot to make this tap function. And we translate that into a mouse click that you see right here. Now, assuming we don't get a tap, then we calculate the position of the head. So we read our new accelerometer values and we pass it to this function here called move mouse calculation. And all we do is pass in the current x value and then the reference x value that we grabbed up here, and the current y and reference y down here. And what we get back is how much we should move the mouse in the x and y direction. And then down here we actually make that mouse move. So this is just a way for us to say, hey, our neutral head position was, let's say 0, 0, and now our instantaneous x is 0.2, so we should move to the right, however much 0.2 translates into pixels on the screen. And so this little function right here is what actually does that move. And if you want to modify these values, go for it. This is the mouse move calculation function up here. You can see what it does is the first thing it does is it says, are we far enough off of our reference value to actually move at all? So if you're finding the mouse moves a little too much, you could increase this value to say 0.1. Now your head has to move at least 0.1 accelerometer values away from neutral before it'll do anything at all. And then down these if statements through here decide how many pixels you're going to move based on how much your head has changed from the reference value. So you see it just as a positive and negative based on if the instantaneous value is positive or negative compared to the reference value right here. And these numbers right here that you see in return integer, those are actually pixel values. So how many pixels should you move to the right or left or up or down is what gets passed from this function, and then the actual mouse move goes right here. Now one more thing before we head out. There's two other, if you're struggling and you want to change the function of this, there's two other useful values that are at the very top of this. It's the shake threshold and the tap threshold. The shake threshold is how hard do you have to shake your head to get the mouse to toggle on or off. So you could try 14.5 or 15 if you are finding that the mouse turns on too often. The tap threshold, maybe you are unable to make the mouse tap when you want it to. You could change this to 75 or 70 and it would tap more often. It would interpret smaller movements in the z-axis as a tap. So if you end up running into those things, go ahead, you can change those values. It's time for a slowed down demo for how this thing works. To turn on the mouse function, you can see right now when I tilt my head, nothing happens. I have to do a hard shake in order to get the mouse function turned on. So now when I move my head up slightly, the mouse moves slowly. Further move up, and it goes quickly. Same thing for down, and right, and left. So you can get a good idea of how much head movement it takes there to get the mouse to move, and the sort of accelerating movement as you actually continually, if you move your head further up and down. Then of course there is the tap function. As we talked about, all you have to do to tap is give a tap of your foot, like so. And then of course the last thing you want to do is turn off the mouse function completely. So to do that, I'm going to shake my head again to the right. Now that was a big enough shake that the mouse is no longer turned on and I can operate normally. Now let me take this camera out of here and actually place it in front of my face so you can get an idea of what it looks like when I'm staring at the screen here. Now we're going to do the same thing. I've put the phone right next to my eye here so that it's recording exactly what I see. I'm going to do a shake of my head to turn the mouse on. And now I'm going to look up and down. And of course, shake to turn it off. This is everything you need to build this project all in one spot. So over on the left, we'll work from left to right. This is all the 3D printed parts. Go download the 3D printable file from the GitHub. That's linked in the description below, and print it on any old 3D printer. This is not special. This is PLA, the most common filament. All the default settings on the printer, 10% infill. If you have questions about how to get a printer going, or you don't have a printer, I'm going to link in the description below to some of my other videos where I've discussed more in depth how to do 3D printing. This shouldn't be a barrier if you've never done it before. It's really not too bad, and you can find 3D printers out in, publicly available if you don't have one yourself. Second, you've got these two mirrors. We're going to cut one of them up. They come in packs of 6 or 8. They're really cheap. Some sort of headgear to mount this to. It could be headphones with music or your chainsaw headset or whatever. Oops, this is still part of the 3D printing here. Some sticky back Velcro so that you can stick this to the 3D printed parts. And then last, the electronics all over here. So this is a Raspberry Pi Pico with headers. It's just got a USB B style plug on it. And then these headers make it so that we don't have to do very much soldering. We can just plug directly into them. This is an accelerometer. So this is where we actually get the position information about how our heads are positioned. And then we've got to wire those things up. So this right here is a stemma plug. It's going to plug into this accelerometer right here, and the other ends of it just plug right in here. That gets rid of most of our solder connections. Unfortunately, this thing does need one pin soldered. This is so that you can detect if there are taps or shakes of the head. That wasn't something that comes out of this port over here. So you do have to make one solder connection to this pin called int over here, and then the other end of that is just going to be able to plug right into the headers of this Raspberry Pi Pico. A couple screws to put it all together, and a dowel. This is a 3/8 inch dowel, and it's about 10 inches long. So these are all the parts that you'll need. Let's see how to assemble it. This is a Pi Pico right here, and I have it connected over here to a Raspberry Pi 5. You can see that over here. The important thing though, you could run this on Mac or Windows. You've got to get this program called Fani installed on your Windows, Mac, or Linux PC. And when you go to plug this in, this is a USB that's connected over here. You have to press this little white button right here called Boot Select before you finish inserting the cable, like that. And then when you let up on everything, it's going to show up as a removable medium. So for now, we don't want to do anything with that. We're going to go ahead and hit cancel over here. And down here on Fani, we're going to say install CircuitPython. And of course, we have a Raspberry Pi Pico H, and we're going to hit install and wait a little bit. After CircuitPython is finished installing, your Raspberry Pi Pico will pop back up as a removable medium inserted. So now we just have a blank install of CircuitPython on this thing. So go ahead and hit OK. It'll bring up this thing as in File Manager. And what we're going to do, you're going to actually head over to Nathan Builds DIY HeadTurner, and you're going to download everything from this directory structure here to your machine. So I've put it in a directory called HeadTurner right here. So, well, I didn't get everything. I grabbed the code py and the lib. And so what you're going to do is you're actually going to copy these things, the everything inside of this lib directory, over onto your CircuitPython device over here. It pops up as a USB device. So just go into lib. I've already got them on here, but you would replace them basically. Yeah, you can overwrite them all. And then you do the same thing for the code.py, where you take this from the HeadTurner GitHub. You just grab that code.py and you copy it over onto your CircuitPython device right here. Well, there we go. So it's going to again replace the code.py that's already there. So now you've loaded everything on there. You've just turned the function of your your Raspberry Pi into a USB mouse that uses the accelerometer you've connected to determine its position. We'll start with the electronics. This is your accelerometer right here. And as I mentioned, I wish this were solderless, but there is a single solder joint right here. It's on the INT pin of this thing, and the other side is a header that can be plugged into the Pico. If you don't have a soldering iron, you can probably bend this so that it's tightly wound there and makes electrical contact, but that's less reliable. I would suggest trying to get a hold of a solder iron. And the rest of these you actually get for free. There's a little harness that plugs right in here. So this is over on the side next to the pin that's labeled V in. You just plug this thing in, and now you have all of these pins over here available to plug into your Raspberry Pi Pico. So this thing gets all of the position information and it passes it to this, and this thing acts like a mouse, like a plug-in mouse for your computer, only it's on your phone, and it's what moves the monitor around. So it interprets all that information and actually sends it over to your phone to control it. So let's go ahead and plug these things in. If you hold it in this orientation right here, the USB plug is over here and the pins are facing up. You're going to put your blue and yellow pins in the corner. So first comes blue, then comes yellow. Then you'll skip a pin and you're going to plug in this one that goes over to the INT pin over here. Now on the other side, you need to skip the first two pins, then plug in your black, and skip a pin and then plug in red. So this is what it'll look like when it's all done. And remember that this one right here is the one that connects to your solder joint INT pin. And that's it. That is all the electronics set up for this thing. We'll actually program this Raspberry Pi Pico with the code that turns it into a mouse in just a moment. But for now, let's finish installing this and getting all of the hardware set up. So the next step is you are going to mount these things into your little bay right here. All you need, this right here is where the Pico is going to sit, and this right here at an angle, you can tell it's been angled so that it sits forward. This is where the accelerometer is going to sit. So I just sink 2 screws into each of them. I make sure the accelerometer is screwed in place tightly, and the Pico is good enough that I can make, easy plugs into the USB port right here. So here goes. Okay, there you have it. All the screws are in place. We've got the diagonal right there. This thing doesn't want to move up or down. And we've got 2 screws in right here holding the Pico in place. Now it's time to stuff these wires down inside here. And this lid has a screw hole right here and a screw hole that matches it right there in the corner. So this will hide all of our electronics out of the way. Electronics hidden, USB port accessible right here. Next up, we need to install the mirror in here. Now these mirrors come with like a cellophane over them, so peel that off. And the first mirror you're going to use is a full-size one. You should be able to just slide it right into position here. And these act as guides over here, so push it as far as you can that way and as far as you can down. And it'll be just a tiny bit loose. You're going to put a tiny piece of transparent tape right up here to hold it in place. So that's practically invisible, holds the thing in place so that it won't fall out as you're moving around. So you get your first in. Now you're going to take your dowel, cut it to 10 inches, and it's going to insert right here. You can also paint this up to give it a little bit nicer look. For now, I'm just going to stick with what I got. It should be a tight compression fit in there. And now for this side over here, these mirrors are actually such that you could leave the top of the mirror here without cutting it, and you'd only have to make one cut along this side. So I'm going to do that. It'll make it just a little bit simpler. Okay, now we can take the tape off. I find that taking this cellophane off afterwards results in fewer cracks on here, although you still are going to get some jaggedy edges. At some point we're going to improve these mirrors so that they are way more bright and reflective, and we'll figure out a better way to cut them at that point. But this is good enough for now. So go ahead and put just a little something on the back to seal this in place. Like so. That's going to stay in place now, and you can fit it onto the end here. Like that. Nice compression fit. And this is what's going to get mounted onto your headgear. So next, grab your headgear. I'm going to use these for now. Put strips of sticky Velcro on one of the sides, and you're going to position these so that it fits right into the little cup of the 3D printed frame here, like so. Now, one thing, these are not going to be mounted perfectly 90 degrees like this. It's actually going to be more like this, so that the eyepiece is more in front of your face. If you did this, it'd be a little too far out to the side. You really have to strain your eyes to the side to see. So you're actually going to position it like this. And the way that you make that happen is you grab two of these arms, and they're slightly different size. I chose, you can see that this one is long, it's going to go on the back side here, and this one is short, it's going to go on the front side. So first thing, we're going to put some Velcro sticky on the inside here, and then we're going to add the arms right up here and connect them to our headgear. All right, now the shorter of the two arms is going to be connected to the front here, what you do is you take the hook part here and you hook it through the little loop and then give it a twist towards the center, like so. Don't do that too hard. You don't want to crack any of this plastic while you're actually making that connection. And then the longer of the two, you're going to do the same thing right over here. Now, you can see that these are going to meet right about there. So let's go ahead and mount these onto here now. I start by pushing these together so that I know that I've got them where I need, and then I push the earpiece into place right here. And now, to actually keep this connection for now, I'm just going to throw a little bit of electrical tape over it. It'll keep it in position. In future revisions, we'll have to make this a more permanent connection and something a little more classy looking. But for now, we can just do something like this. All right, so now with all of that mounted, this part right here sticks on real tight, and this part right here keeps the whole thing from shifting back and forth. So when we put this on our head, we should be able to see right in here. And we can actually give it a quick test by dropping a phone in, sticking it on our head. Go ahead and do that now and make sure that all the optics work out for you. You should be able to see this surface right in here. I'm giving it a test, and it looks great. I can see right in there. Last thing, you can of course use different types of headgear. All you have to do is put those same strips of Velcro on the outside and select appropriately lengthed arms. So these are just a little bit shorter than what's in use over here because that's not sticking out quite as far from your head. For something like this, you may have to use a little bit longer arms because it's got a lot of distance to travel there. But you can use just about any solidly mounted headgear on your head. Put this thing on the side and choose appropriately lengthed arms right here so that you can stick it all together. This device is not limited to working with just your phone. It's simply a USB mouse. So if you want, you can plug it back into your computer. You remember we used a Raspberry Pi 5 to program this thing. I went ahead and plugged it back into the USB here, and I'll hold this in my hand, give it a shake, and you can see that the mouse on the screen here can move up and down with this thing moving up and down. It's a USB mouse that works with any old device, so you could control your computer or your phone or anything else that you just want to plug it into.
So there you have it. This thing works surprisingly well for a prototype. Looking forward to the next revision of it, I see two main areas that could be worked on. The first is I'd like to get more multimodal inputs so that you can do more control over the phone. I'm thinking gestures. Swipe up, swipe left, pinch to zoom, or maybe execute a series of commands. If you always open an app and click on the keyboard function or something like that, being able to issue a series of commands based on another input. So more than just controlling a mouse and clicking. I think there's a lot of ways that you could do that. One would be voice commands. So as soon as you turn the mouse on, you could take voice commands to do more complicated series of actions on the phone. You could instead put EEG sensors on your head. Those may be a little uncomfortable to be wearing all day, but you could then, think what you want to happen on the phone and make it happen. There's also, I thought about maybe putting a camera out here and then watching the eyes. It's really hard to do precise eye tracking, so I don't think it would be like looking at where you're looking on the screen and moving the mouse, but you course do coarse-grained things like move your eyes left, move your eyes right, raise your eyebrows, blink. Those kind of things would be easy to detect, and you could take actions based on those. And then, of course, you could just use the accelerometer that's in there. If you install TinyML on this Raspberry Pi Pico, and then you do like a series of actions that the accelerometer reads, that could be interpreted by the machine learning as a particular gesture that you want to take some action. So first off is how to get more inputs and then control the phone more in a more complicated way. So that's one. And then the second area that I think could be explored is getting this information into a display in front of your eyes. It doesn't have to be these couple mirrors that you see here. You could mount the phone somewhere else. So like back of your head, top of your head, and then follow a different reflection path to get the information in front of your eyes. And that may be more comfortable. I put it here on the earpiece because I often wear hearing protection and headphones, but it doesn't have to be there. And then you could go a totally different route. You could get like a short throw projector and mount it somewhere on yourself so that you can turn it on and see things as needed, or just smart glasses. Those are both pretty expensive options. Smart glasses are at least $100 for a good pair right now, and a short throw projector that would work is like probably over $200. But the idea would be, in each case, you can get the same information of what's on the screen in front of your eyes in a different way. This I feel a little better about because if I break it while I'm out working, it's like $10 and I can fix it myself. Those are a little bit more expensive, but if you've got ideas about what the next version of this should look like, whether it's control or display or whatever, let me know in the comments. I'm interested in trying to develop this and just see what becomes of it. It's definitely a hot area and not one that I found like a product out there right now that does just what I want. So I'm trying to build it myself. Let me know what you think.
Let me know what you think in the comments, and don't forget to like and subscribe for more unique and useful do-it-yourself builds.